Hello everyone, my name is Wycliffe Agumba, and today I want to share with you a session on how to use your own region of interest GeoJSON file or shapefile to run analysis or to interact with Google Earth Engine in Google Colab. So normally what we do is that we tell the user to draw a region of interest or something like that using the drawing toolbox or the drawing options we have. Just set options here to have satellite. It's the default. So normally we use these toolbars to draw a region of interest like this, and then that becomes the geometry which you can use down for your own analysis. But then this is not normally the case with every individual, because everyone could be having their own shapefile or GeoJSON file that they want to use to as the bounding boxes, and how to get that done becomes a problem to some people. Well, in Google Earth Engine code editor here, you can upload your assets, especially shapefiles, and then import them or load them in your current session and continue working with them downstream. But then how is the case when it comes to Google Colab? So here I will show you how you can use your own region of interest to run some analysis. For example, you want to know maybe the height or the elevation or minimum or maximum elevation at your location or your area of interest. How do you go about that? So we'll start by importing the necessary libraries, which is EE and GMap. Those are the two libraries that we need. And then we use the EE to authenticate, basically to allow Colab use our Earth Engine credentials, our Google credentials, and then we initialize the account using the project ID. So our project ID is normally under our project name here. We go to project info, and then you copy this ID under cloud project. Then we bring that to our Colab. Something is not right. EE has no attribute authenticate. Authenticate, so that's typing error. Okay. It's asking us to allow Google to use. Then I select my account, my Gmail account for this. Again, it's asking me to verify this information, which is a rare phenomenon, but I see it here now. Normally this doesn't happen, but I don't know. Google just wants to be sure that I'm the real owner of this account, which of course is the case. Okay, so after the authentication is done, normally that should go without any problem. We can create a map, just like we have in the code editor. gmap.map function, and then we set base map to be satellite. We can visualize our map, and normally what we or what trainers will be talking about is that, okay, let's decide on our area of interest. I'm interested in any location globally that has got tea. So this is a tea growing region in Kenya. And if we want to just do our analysis within this bounding box, then we can draw the last feature. So we can call it our region of interest is from the map, we draw the last feature, and then we get the geometry of that last feature. So if we check the region of interest, we notice it's a polygon with all this. And then we can use this ROI, which is this bounding box here, to do our analysis. For example, if you want to know the elevation, then we can get elevation data, which is SRTM, this one. Then we copy the snippet for that, and we say our SRTM is equal to tuple, and inside the tuple we put the image, and then we can call the SRTM, which is an image, USGS SRTM this. So this is elevation data, or altitude data. So we can know the altitude, the mean altitude within this bounding box, the minimum, the maximum altitude. We can get all that information if we want, because we can reduce with the, we can do a reducer on our region of interest. For example, I can just do a quick one, like mean elevation is equal to the SRTM we have as our image. Then we reduce a region, because we have a region of interest within which we can reduce. And then our reducer, for example, is the mean. So use reducer called mean. And then after we have applied the reducer called mean, we can say the geometry around which we want to do the reduction is within the bounding box, which is the ROI. Then we are also interested in providing the scale of our analysis. The data is at a scale of 30 meters. If you check SRTM, it's already written there 30 meters, and normally they indicate the resolution. So it's 30 meters. So we want to do analysis at that scale because our region of interest is relatively small and will not be computationally expensive for the servers. So we can print our mean elevation, which gives us an object here indicating the elevation. The mean elevation in that location is around 2,053 meters above the sea level. So quite high altitude region where tea is grown. But then we have just drawn this bounding box or region of interest. What about if you have your own region of interest from wherever you get it? You got it. So let's say you got your region of interest from global administrative boundaries, like using geodata. We can say, for example, we need the administrative boundaries for Kenya. Then we call GADM function or GADM function. And then we provide the name of the country as Kenya. So that's the country we need its administrative boundaries. And then the level of analysis is the least, the finest level available, which is level 3. If you say level 0, you will get just the boundary of Kenya alone. If you do level 1, you will get the major administrative regions of Kenya, which are the counties, and then sub-counties, and then wards. After level 3, we can also add path. I think so. Yeah. So path. For now, I just want to use a temporary directory. So if I run this, of course, you need to have internet connection to get data from these global administrative boundaries. Once you've gotten the data, it's around 14 MBs, so not so huge. If you, for example, plot 10, you will see that it's quite dense plot with so many polygons. Those are the administrative regions in Kenya. So we just want to pick one of them. And if you check Ken, if you print it in the console, you see it has got a number of columns like name 1, name 2, and we also have name 3. So this name 1 are the counties, like Baringo is county. We have name 2, which could be Baringo Central, that's a sub-county. And then we have name 3, which is like Lembos, Chapchap, Kabarnet. Those are now like wards. So we want one of the smallest which falls around our region of interest. Well, that is based on my knowledge of the region of interest. So I can just say our region of interest is now going to be Ken, and then we subset this Ken based on name 3, and only where that name 3 is exactly called Kipchebor. So if we do that, we get, if we can now plot our region of interest, then it is just one polygon. Out of these dense polygons in Kenya, we picked one around this western part of Kenya. And it is called Kipchebor, a small polygon. So I'm just saying one of the ways through which you can get your region of interest. Maybe the region of interest was given to you by a friend, or you drew it yourself in Google, in QGIS or ArcGIS or whatever shapefile or GeoJSON file you ended up with. It doesn't matter. So this is just a demo of how you can get one of your region of interest or shapefiles. But for this, I will use a GeoJSON. So I will just write it in the home folder. I will not create an output folder or something. I will just call it region of interest 2, because already we created one there. So I will save it as a GeoJSON. So if we run that, we see our GeoJSON written here as a file. So it's a file for only this subset of the many polygons we have in Kenya. I didn't want to import all of them. So we have this. Okay, let's get back to our Colab. And in this Colab now, we can create a region of interest 2, which is, we will use GMap to get the region of interest, which is GMap, GeoJSON, because our object is in GeoJSON format. So we want to convert it to from GeoJSON to Earth Engine. But then we have to upload it to the current content folder, current working directory we have here. So we will upload that. I'll go to, it's called, I think this, yeah, this one. I open that. It shows you some warning that ensure that your files are saved elsewhere. Because when you have it in Google Colab, the moment the runtime is stopped, then you lose everything here. So make sure you don't delete it in your local directory. Or you can again download the whole Kenyan and then subset it if you still want it later. But then that's just a nice warning. So we can then provide the path to that, which is region of interest 2.geojson. So if we run it, we will see a feature collection. So already our GeoJSON has been made relevant for analysis in Google Earth Engine. I mean, super straightforward. So we can duplicate the analysis we were doing here about the mean elevation of our region of interest down here, but we change our ROI to be ROI2, because ROI2 is our new region of interest, which is our own shapefile. Normally what you will need, what you will use for your own analysis. To just see the value, to ignore this object one property, we can say values and then get the first one, because it's just one object. So we get the 0th. That gives us just the actual value. So this is the mean elevation. We can also get the maximum elevation around this region. This is the maximum elevation in our new region of interest, which is now different from this. Yeah. You can get maximum, you can get minimum, you can get standard deviation, STD dev, I think. Yeah. Standard deviation, like plus or minus around the mean. deviation of individual values or dispersion of values around the mean, you can get all that. So if you have your own region of interest and your supervisor or professor is telling you what is the general description of elevation in your region of interest, then you don't need to worry about the fact that you only know how to draw a square using the tools provided here or the polygon or a point, but you also have the luxury of bringing in your own region of interest and then using it to get the values you need: minimum elevation, maximum elevation, rainfall, temperatures, NDVI, whatever it is that you want around this region. Over time series analysis, all other analysis you can do with this. And just to confirm that what we are using as ROI2 is really different from ROI1. We can create a map 1, which is map.map using a base map of satellite. And then we say to map 1, add a layer. And the layer you are adding is ROI2. And then show us that map 1, please. Okay, the other thing which we can do here, now I'm starting to think, is to center object around our region of interest 2, and then zoom it to around 15. Will that bring it closer to our eyes? But now we have not called it 1. Okay. Yeah, so that's 2 zoomed in, maybe 12. Okay, so you can see now the region of interest we are dealing with is different from the ROI which we just drew with a rectangle. This is the Kipchebor region in this tea growing region of Kenya, and we just got it from global administrative boundaries and managed to use it to do our analysis in Google Earth Engine. And we can plot it here and see. I think we can also add it as an image. Not really. We can just paint the borders. How are we doing that? ee.image and then .paint. It's a while since I did this. I think it will still work. And then width is equal to maybe 4. And then what do we do here? We provide palette. We can tell it to use a palette, color palette of red. Fingers crossed. Perfect. So we can, by using this paint and all this, we are converting the vector to kind of a pixel kind of raster, but then only the borders are considered. So you can actually see the boundary clearer than if we just added the to map 1, if we just added layer without without converting it to an image. So that one, this was just a vector with some field, and to remove the inner fill and only fill the lines is a bit complicated. The easiest way is just to paint it as an image and then ignore the rest. Yeah, so this was just a quick show of that. Don't just rely or get entangled in using the drawing toolbox here to draw your region of interest and then start analysis, because sometimes you really need something specific to your own region of interest. So it's important that you know how to bring your own region of interest into the Earth Engine coding session and then use it downstream to run all your analysis and you can visualize it to confirm the same. Thank you.